March 7, 1945. Remagen, Germany. Rhine River. 1600 hours. First Lieutenant Karl Timmermann, 23. Company A, 27th Armored Infantry Battalion, stared at the Ludendorff Bridge. Still standing. German demolitions had failed. His platoon was about to cross the Rhine on foot, under fire. Behind him, engineers from the 291st Combat Engineer Battalion were setting up equipment. Bridge might collapse any minute. They needed backup crossings. Fast German doctrine said, "One bridge takes 3 days to build. Rhine is 300 meters wide here. Americans will need a week minimum to establish alternate crossings." What the Wehrmacht didn't know, American engineers had equipment that could span the Rhine in under 24 hours, and they were about to demonstrate it 25 times across Europe. By March 1945, the Allied advance had reached Germany's final natural barrier, the Rhine River. 800 miles long, 250 to 400 meters wide in most places, defended by German forces ordered to destroy every bridge. Military history said rivers this size stopped armies. Crossing required massive preparation, bridging equipment, engineer battalions, air superiority, and time. Lots of time. Traditional military bridges came in types: fixed bridges, permanent structures, months to build. Bailey bridges, British prefabricated design, excellent but required assembly time and specialized equipment. Pontoon bridges, floating spans on boats, used since Roman times, slow to emplace. The U.S. Army had developed something different. The M2 Treadway Bridge, a tactical pontoon bridge designed for rapid deployment. Standard components, pneumatic floats, steel treadway sections, and connecting hardware. 2-lane capacity. Could support 40-ton vehicles. Maximum span, 1,100 feet. Critical specification. Construction time under ideal conditions, 8 hours for 400-foot span. Under combat conditions, 12 to 18 hours. German intelligence had photographs of the equipment, assessed it as capable but conventional. Nobody expected what American engineers could do with it when pushed. The Remagen bridge capture on March 7th gave First Army its first Rhine crossing. But the bridge was damaged. Engineers found demolition charges still attached. Some misfired. Structure could collapse any time. General Omar Bradley ordered, "Get alternate bridges across immediately. We need capacity for armor and supplies." Engineer battalions converged on Remagen, 291st, 51st, 276th. They brought treadway equipment, Bailey components, and orders to span the Rhine as fast as mechanically possible. What happened next became a case study in military engineering. At 2200 hours, March 7th, less than 6 hours after infantry crossed the damaged Ludendorff Bridge, engineers began assembling the first treadway bridge 400 meters downstream. Work continued through the night under spotlights and German artillery fire. The treadway system worked like this: pneumatic floats, 33 feet long, 5 feet wide, inflated with compressed air. Steel treadway sections, 13 feet long, 10 feet wide, locked together to form the roadway. Engineers connected floats in the water, then laid treadway sections across them. Each float supported one treadway section. Speed came from standardization. Every component identical. Every connection the same. Engineers didn't need to think, just execute the practiced sequence. Float in water. Connect to previous float. Lay treadway. Lock it down. Move to next section. At 0930 hours, March 8th, the first treadway bridge opened. Construction time, 11 hours. Length, 380 meters. First vehicles across, M4 Sherman tanks weighing 33 tons each. Bridge held German observers across the river reported to headquarters. Americans completed Rhine crossing bridge in half a day. Previous intelligence estimates were incorrect. Wehrmacht engineering manual specified, bridge of this length requires minimum 3 days with optimal conditions. American completion time suggests either pre-positioned materials or construction methods unknown to us. Neither was correct. American methods were known: standardized components, trained crews, practiced procedures, What German estimates hadn't accounted for, American engineers treated bridge building like an assembly line. Each crew specialized in one task. Efficiency came from repetition. By March 10th, 3 treadway bridges were operating at Remagen. Traffic capacity: 2,500 vehicles per day. On March 15th, engineers completed a 4th bridge. Total construction time for all 4: 62 hours of actual work spread across 8 days. March 17th, the damaged Ludendorff Bridge collapsed, killing 28 engineers working on it. But by then, the 4 treadway bridges were handling all traffic. The collapse barely slowed operations. Other armies would have been stranded. First Army had enough capacity to support 3 armored divisions across the Rhine simultaneously. German General Alfred Schlemm, commanding opposite Remagen, sent report to OB West headquarters. American bridging capability exceeds all previous estimates. They are crossing the Rhine as if it were a minor river. Our demolitions are ineffective if they can bridge this quickly. Recommend immediate countermeasures. Countermeasures came too late. By March 23rd, Third Army under Patton crossed the Rhine at Oppenheim. Engineers had Treadway Bridge completed in 10 hours. Patton's famous call to Bradley, "We're across," without losing a man. "Want to surprise you. Drove across a Treadway Bridge this morning. Your engineers are magicians." Ninth Army crossed at Wesel on March 24th. Engineers completed 3 treadway bridges in 18 hours, despite German artillery and air attacks. First armored vehicles crossed while engineers were still completing the far end. The pattern repeated across Germany. Everywhere Allied forces reached a river, engineers bridged it within 24 hours. Rhine, Main, Danube, Elbe. Component standardization meant bridges could be built anywhere, anytime. Statistics tell the story. From March 7th to April 30th, U.S. Army engineers constructed 62 treadway bridges across German rivers. Average construction time: 14 hours. Longest bridge: 146 feet across the Rhine at Wesel. Shortest time: 8 hours across the main river. Total traffic capacity: over 150,000 vehicles crossed these bridges during the last 2 months of war. Compare that to German bridging capabilities. Wehrmacht engineers required an average of 48 hours to complete a pontoon bridge of similar length. They lacked standardized components. Each bridge was custom engineered for the specific site. Construction was slower, required more personnel, and produced lower traffic capacity. Captured German engineering officer, Major Heinrich Müller, 217th Engineer Battalion, was interrogated after surrender. Asked about American bridging operations, his response was recorded. "We watched through binoculars as American engineers assembled Rhine bridges. We could not understand the speed. Our doctrine says such bridges require days. They completed them in hours. When I saw the standardized components, I understood. Every piece identical. No measuring, no cutting, no fitting. Just connect and move to next section. Simple, but brilliant." He continued, "Our engineers were better trained individually. American engineers were better organized systematically. In war, system beats skill." That observation became doctrine post-war. Modern military engineering emphasizes standardization over customization, speed over perfection, practiced procedures over creative solutions. The M2 Treadway Bridge became the standard until the 1960s, replaced by the M4 T6 Bridge, which used the same principles with improved materials. That was replaced by the improved Ribbon Bridge in the 1980s. Modern version, the Joint Assault Bridge, can span 200 feet in under 5 minutes. But the core concept remains: standardized components, trained crews, rapid deployment. The strategic impact was decisive. Germany's defense strategy relied on rivers as barriers. Hold the attacker at the river, buy time to regroup, counterattack during the vulnerable crossing phase. That strategy assumed crossing would take days, maybe weeks. Give defenders time to concentrate forces, prepare counterattacks, bring up reserves. Instead, American forces crossed rivers faster than German forces could react. By the time Wehrmacht commanders identified a crossing point, and ordered units to respond, Allied armor was already across and advancing. General Dwight Eisenhower stated in April 1945, "The speed of our advance in Germany is directly attributable to our engineering capabilities. We cross rivers faster than the enemy can respond. That's turned every river from a barrier into merely a delay. And in mobile warfare, eliminating delays wins campaigns." German Field Marshal Kesselring, defending southern Germany, wrote in his April 20th situation report, "American bridging capacity has made river defense untenable. They cross faster than we can destroy bridges. Recommend withdrawal to defensive positions not dependent on river lines." But by April, there were no positions left. The war ended 3 weeks later. Post-war analysis by U.S. Army Corps of Engineers calculated standard bridge construction time saved in European theater. Approximately 3,000 man-days per bridge. Total bridges constructed 304. Time saved 912,000 man-days. Equivalent to keeping 10 engineer battalions out of combat for entire campaign. Translated to operational advantage. 3 weeks saved in campaign timeline. 3 weeks doesn't sound dramatic. But in April-May 1945, 3 weeks was the difference between war ending in May versus June or July. That meant fewer casualties, less destruction, faster transition to occupation and rebuilding. The soldiers who crossed those bridges rarely thought about the engineering. To them, bridges just appeared. Armor rolled across. Infantry followed. War continued. But to the engineers building them, each bridge was 12 hours of back-breaking work under fire. Assembling floats in cold water. Connecting treadways while artillery landed nearby. Working through exhaustion because the schedule said this bridge opens at dawn. Staff Sergeant Robert Billings, 291st Engineers, worked on the first Remagen treadway bridge. Interviewed in 1989, age 68, he remembered, "We worked all night. German artillery kept landing close. Water was freezing. But we had a timeline. Bridge opens 0800. No excuses. We opened at 0930. Apologized for being late. Command said 2 hours late is still record time. We just did our job." He added, "Nobody remembers the engineers. They remember Patton crossing the Rhine. They remember the infantry taking Berlin. But someone had to build the bridges first. That was us. We didn't mind being forgotten, as long as the bridges held." Another engineer, Corporal James Mitchell, 51st Engineers, was part of the crew that built the Wesel Bridge, the longest treadway of the war, 146 feet, completed in 18 hours. He recalled in 1995 interview, "We knew we were setting a record. Officers kept telling us, longest bridge, fastest time. But we weren't thinking about records. We were thinking, get this done so the boys can cross." Every hour we saved was an hour the infantry wasn't sitting exposed on the West Bank. German witnesses provided perspective. Oberst Franz Weber, artillery observer, watched American engineers build a Rhine bridge from across the river. His diary entry, March 12, 1945, observed American bridge construction today. Astonished by the speed and organization. They work like a factory. Each man knows his task. No hesitation. No confusion. Bridge appeared to grow across the river like a living thing. We fired artillery but couldn't stop them. For every section we destroyed, they had another ready. By evening, bridge was complete. Watched American tanks cross. Knew then the war was lost. That diary was found after his capture. Weber survived the war, became a civil engineer in Munich. In 1978 lecture at Technical University of Munich, he told students, "I learned more about engineering watching American combat engineers in 1945 than in all my military training. They showed me that the best engineering is not the most clever. It's the most reliable under pressure. Simplicity, standardization, speed. Those win wars." Today, the M2 Treadway Bridge is displayed at the U.S. Army Engineer Museum at Fort Leonard Wood. Components laid out to show the system. Veterans visit and point to the floats, the treadways, the connections. Tell their grandchildren, "I built bridges with these." We crossed every river in Germany, opened the way for Patton and Hodges and Simpson. War ended faster because we could build bridges in a day instead of a week. There's a guest book at the exhibit. Entry from 2004, from a German visitor. My grandfather was Wehrmacht engineer. He told me about watching Americans build Rhine bridges. He said it was like watching magic. Bridge appeared overnight. Now I see the components. It's not magic. It's brilliant design. Thank you for showing us how you won. The lesson isn't about bridges. It's about systems. When you design something for speed, you sacrifice customization. Make everything identical. Train people on one method. Practice until it's automatic. That's how you move faster than your opponent expects. Rhine River was supposed to delay the Allies for weeks. Instead, it delayed them for hours. Not because American engineers were better trained, because American engineering systems were better designed. Next time you face a repeated task, ask, what if we standardized this? What if every time looked identical? How fast could we go? You might sacrifice elegance, might give up optimization for each individual case, but you gain speed. And in competition, speed often matters more than perfection. March 1945. American engineers crossed 25 rivers in 72 hours. Wehrmacht couldn't believe it. The answer: identical components, trained crews, practiced procedures, not glamorous, not innovative, just relentlessly efficient, and that's usually enough to win.